और भाई कैसे हो? तो चलिए देखते हैं आज के क्वेश्चन। मैं इसको यार फिर से रिकॉर्ड कर रहा हूँ, मैंने करा अभी भी, इसमें आवाज़ नहीं आई। सैड हो गया मेरे साथ। So let's see what do we have today's question. So we have given sorted GCD pair queries. So it's just a continuation of what we had in the previous 2 3 days. So we are going to use all the properties that we have seen there. Okay. So we have given nums of length n and we have given queries. What do we have to do? First, right, there is a GCD pair that denote an array with GCD of all possible pairs, right? So that is GCD of all possible pairs, right? Okay, the next is right, then sort GCD of all pairs and sort in ascending order. You need to find the element and index, right? So in GCD of pairs, we need to find the queries of I. So let's say, right, this is the final GCD, right? After sorting some till 9, right? So then we have to give the right queries of I. Let's say they have given 4, right? So what is the 4 index, right? This 4. So we have to return this. So this is question. So what does the question says first? So let's see the constraints as well, right? Constraint is 10 raised to power 5, 10 raised to power 5, queries 10 raised to power 5. And this is a, queries of I can be n into n minus 1 by 2. So this is supported in long only. Okay, now let's see the, if we do the brute force, right? What is the first step, right? GCD of all pairs. Second step is right. So third answer queries. Now tell me one thing. The time complexity for GCD of L pairs is n cross n, right? So if we sort right, then the time complexity will be right n log n. So m log n, right? M is size of GCD pair, and what can be the size, right? Total there are n, right? N values. The pairs will be rolled n into n minus 1 by 2. So if there are like 4 elements, what is the total pairs, right? 4 into 3 by 2, right? That is 4 plus 3 plus 2, 1, right? That is arithmetic basic, right? What is the formula that we do? If, right, the basically the first one d minus 1 by 2. So n minus 1, right? The common is n divided by 2. Okay. So this will give us TLE, this will give us MLE, and this will give us result. So this will not work. Okay. Now, okay, now we have to find some other approach. So one thing we are clear since, right, we have written, right, ascending plus answer queries, right? This is going to be a binary search. Okay, so one we have to apply binary search. Now binary search on ascending, right? Now we have to identify, right? We have to identify this. Identify GCD pairs. Now, how we can do it efficiently? See, we cannot do brute force, right? But but see this condition, right? See, nums of I is less than 5 into 10 raised to power 4. Then what is the property of GCD, right? GCD of two numbers, right, which always be less than equals to maximum of a comma b, right? Since n is 5 into 10 raised to power 4, can I say, right, GCD of all pairs will never exceed 5 into 10 raised to power 4, will always less than equals to, right? This is correct. Absolutely correct. Okay. So then what will do? We find the maximum element in array. One step, right? Maximum element in array. Now, the next question is, right? So, see, instead of finding GCD of all pairs and sorting, right? Since we know, right, this all values, our GCD pairs, sorted array, right? This is going to be now 1, 2, right? Max. So that means this count, right? Total count is n into n plus n minus 1 by 2. And right, but the values are limited between 1 to max. So can I have this right, that count this, let's say 1 appears 2 times, 3 appears 5 times, and so on till max appears some n number of times. Can I say this thing? Just think about this, right? Can I have this thing? Then can I apply binary search on it? Yes. How? By doing prefix. By doing prefix sum. And now the question remains, right? Now the question is how to find, right? Next question is, right? Now we are at the step where how to find, right? How to find all pairs whose GCD equals to some G, right? This is what we have reached, right? Since, right, GCD can be between 1 to max only, right? So let's say I give you 3, right? And I ask you how many pairs of GCD equals to 3, right? This is the question that we have to answer now. Okay, now tell me one more thing. Let's say I have an element A which is x into some x multiply by y. I have B which is x multiply by z. I have C which is x cross x multiply by some z. I have D which is x multiply by x multiply by w. Then see, right, if I say GCD of A comma B, then I say this will be always greater than equals to x and a divisor of it, right? Why? So see, both of these have a common divisor b, right? So this is correct, right? So I can say GCD of x into y comma x into z. So I can say x multiply GCD of y comma z. Can I say this one, right? Now the same apply for this one, same apply for this one. So can I say, if nums of I, any nums of I has divisors, say x, y, z, then can I say, right, at least, right, GCD will be at least, right, GCD will be at least x, right, for all nums of I, right, whose divisor is x. Can I say this thing? Tell me. So let's say you have three numbers, right? 2 multiply 1, you have 4, right, which is 2 into 2. Then you have 6 number, 6, which is 2 into 3. Can I say in all of these, right, if I make a pair of 2 comma 4, I make a 2 comma 6, I make a 4 comma 6. So their GCD is at least 2, right? Because all of them have a 2 common, right? Okay, so now we are again question, right? So next thing what we are going to do, right? Find, right, count of pairs whose GCD, right, is at least G. See, if their GCD is G, I can say at least G, right? What can be the other, right? So you say this example, like let's take a new example, right? I said, right, 2, which is 2 cross 1. 4 is what? 2 cross 2. 8 is what? 2 cross 2 cross 2, right? So tell me one thing. At least 2 GCD is, right? 2 comma 4, right? 4 comma 8 and 2 comma 8, right? They are at least 2, right? Now, at least 4 equals to what, right? They are at 4 common, right? So they will be, right, 4 comma 8, 4 comma 8 only, right? Now then tell me what is exactly 2? Exactly 2 is what? At least 2 minus at least 4. Is this true? And what will be at least 4? Which is right, at least 8. At least 4 is what? Sorry, exactly 4 is what? At least 4 minus at least 8. So, right, first we found count of pairs whose GCD is at least G. Then what do we found? Find, right, found count of pairs, right, whose GCD exactly G. This is exactly. Okay, so once we have this thing right, so then right, we have exactly the G, it can be sorted, right? If we make an array, it's always sorted, right? Then we calculate prefix 6, right? Apply binary search. It's very easy question, you see. Now we are able to answer this, right? Now, how to do this thing, right? At least G, okay. Let's say max is the max element in the array, right? Then what do you do, right? You, for I equals to 1 till m, right? Now for what do you do? J equals to I, j less than equals to what? Max, right? Now do j plus equals to I. You go, you're right. We always have to check all the multiples of j, right? Multiples of I. So I can say, right? Can I say GCD at least, right? I plus equals to, right? Whatever is the count of j, right? Whatever is the frequency of j. Okay, so this will give us GCD of at least array. Now we need exact array. How can I prepare the exact one basically, right? If then I start from reverse and I keep subtracting the above one. So let's say for I equals to max, I do I greater than equals to 1, I minus minus, and for each I, right, I subtract it's all about divisors, right? So I say, right, j equals to what, 2 times I all above, or what do we do it, right? J minus I, right? J less than equals to max, j plus equals to I, right? It's increase in terms of I. So what is my GC of exact? What is the GCD of exact of I? Right, minus equals to, right, what? GCD of at least what? J. And here you add, right, GCD of exact I equals to GCD of at least I. So now we go to GCD of exact I. Now prefix is easy, right? You can do sort, you can apply prefix, you can do binary search. Binary search is, let me tell you how this will work. So let's say you have one, right, whose count is 2, 3 whose count is 2, then 4 whose count is 1, right? Then the prefix array will be what? What is this? Okay. So now how they will look in pairs, right? 1, 1, 3, 3, and 4. If you have to find which is at second place, what it will be, right? 1. So if you have to find the prefix, what you will do, right? Prefix is what? 2. What is 2 plus 2? 4. What is 4 plus 1? 5. Right? Then you have to find the position, right? Position is plus 1th element, right? So you will do, right? If you need for 2, you will do. Okay, what you will do, right? You can simply say lower bound, right? Lower bound of queries of I plus 1. So what is it for the 2? That is 3. So the position will be, what's it say? 2 it will return. Okay. Now the what is the time complexity? Time complexity is, right, n cross, right? What is the time complexity of this function? Finding exactly or at least g. It is n cross whatever the steps increase it. What is it? That's logarithm of n, I think. Okay, yeah. Think you will see the code part now. I'll show you the code part. I have just completed it few seconds ago. I don't want to do it again. So I'll show you. Okay, I'll show you step by step, right? This is the first element. First step is the line 5, right? Where we calculate the max element. We then calculate the frequency of each element, right? Once we have the frequency, then we prepare the GCD of at least, right? The second step, right? You see, calculate pairs with GCD at least G. So what do we do? So we for I want to right max, we do I, we steps in we increase in steps of I, and we add it to the GCD, right? Whatever the frequency. Then we prepare the count of pairs. Count of, for example, let's say there are five elements, right? Whose divisor is five. Then what is the count of pairs, right? 5 into 4 minus 1 by 2. So we'll calculate the count of pairs for GCD of I. After calculating count of pairs, we will calculate the exactly GCD equals to G. We'll subtract the above one. Okay, then we calculate the prefix one, then we apply the lower bound, and then we return the answer. I just did it few seconds ago. I'm just lazy, okay? And there was no voice in that video, so I have to do it again. So we can submit and we can check the time complexity actually. Okay, so you see this works. Let me see what the analysis says. I think it will say good only. So, right, if you always, so for the hard problems, right, always first identify the steps that you need to do before started coding, right? So it asking, can you queries an off one after pre-processing? Can we do it? Maybe I'll check. But you see time complexity is m log n plus q log n. Okay, clean and well structured, that is fine. So how can you answer the queries in O of one after pre-processing? Mm, mm, I think you can store in unordered map and you can store the range. So then you directly search for it. I think that will work. Then unordered map will answer as the queries in O of one. Yeah. Let's see what people are done. Okay, reduce GCD for prefix sum of right. They use the right answer queries. They use the upper bound. This is not O of one solution. Is this the O of one? This is the O of one, right? They applied the queries. No, this is also overall logarithm one. But O of one will be, I think, to store in the unordered map. Then we have the range. Then we can directly query it. Okay, thank you.